Here's my solution to that geometry puzzle I showed you the other day. In case you didn't see it, here's what the question was asking. You have a circle with diameter 1, and you have inscribed a regular hexagon, and you've circumscribed a regular hexagon. So this regular hexagon here, the corners are touching the circle, and that regular hexagon outside, it's tangent to the circle. And then the question is, what is the difference in the perimeters? In other words, what's the big perimeter minus the little perimeter of those two hexagons? So here's how I did it. This radius here, and that radius is 1/2. But that radius there is also 1/2, and because this is a 60-degree angle, this is an equilateral triangle, so that side is also 1/2, and there are 6 sides. So the little perimeter of the little hexagon is just 6 times 1/2, which is equal to 3. Now we can do the same thing for the big hexagon. The problem is the radius doesn't actually come all the way to the edge of the triangle there. It sort of stops in the middle. So when I draw the radius here, that radius is 1/2, but you can still draw this equilateral triangle. And now you know the height of that equilateral triangle is exactly 1/2. Using properties of 30, 60, 90 right triangles, I know that this side has to be 1/2√3. But there are 2 sides because there's that part and that part. So you double it. And that means the whole side, the whole length here is 1/√3. Again, how many sides are there? There's 6. So the perimeter of the big hexagon is 6 times 1/√3. If you do a little bit of algebra, so the answer is 2√3 minus 3. And you might be wondering, why did I make the diameter 1 instead of 2? Because you might want the radius to be 1. Well, this is actually the first step in Archimedes' way to approximate the value of pi. So what he needed was the perimeter of the inner circle to be pi, and then you have a lower bound and an upper bound, and that's what those 2 numbers are. So that's the answer. If you got it right, great, congratulations. And if you didn't, that's okay, keep trying. You're gonna keep giving you more puzzles like this. Give me a follow if you wanna learn more, or if you have any questions. Thanks, guys.